Welcome to Math Tutorials. In this video, we are solving every question of exercise 3.1 of Chapter 3, Matrices, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 3.1 has 10 questions covering the basics of matrices, orders and elements, constructing matrices from formulas, and equality of matrices. Here are the questions. Let's start with question 1. Question 1. Here is a matrix with 3 rows and 4 columns, and 3 things to read off it: its order, its number of elements, and 5 specific entries. The order counts rows by columns. 3 rows, 4 columns, order 3 by 4. The number of elements is the product. 3 times 4 is 12. For the entries, a ij means row I, column j. Row 1, column 3 is 19, and row 2, column 1 is 35. Row 3, column 3 is -5. Row 2, column 4 is 12, and row 2, column 3 is 5 halves. Question 2. A matrix of 24 elements. Every way of writing 24 as rows times columns is a possible order. And then the same question for 13. List the factor pairs of 24 in order. Each pair gives an order in both arrangements, 8 possible orders in all. 13 is prime, so only the 2 extreme shapes exist, a row or a column. Question 3. The same game with 18 elements, and with 5, another prime. The factor pairs of 18, 1 and 18, 2 and 9, 3 and 6. Both arrangements of each pair give 6 possible orders. And 5, being prime, allows only a single row or a single column. Question 4. 3 formulas, each generating its own 2 by 2 matrix. We substitute every row-column pair. In each case, I is the row number, and j is the column number. Formula 1, I plus j squared over 2. The 4 entries, 2, 9 halves, and 8. Assembled as a matrix. Formula 2, I over j gives 1, 1/2, 2, 1. Formula 3, I plus 2j squared over 2 giving 9 halves, 25 halves, 8 and 18. Question 5. The same construction game at size 3 by 4, 12 entries per matrix. Formula 2 has no modulus, so negative entries survive. Formula 1, row by row. Row 1 gives 1, 1/2, 0, 1/2. Rows 2 and 3 the same way, assembling the full matrix. Formula 2, 2i minus j, row by row, the entries fall by 1 along each row. Question 6. Equal matrices mean equal corresponding entries. That turns each part into ordinary equations. Parts 2 and 3 need a little solving, not just reading. Part 1 match the entries directly. X is 1, Y is 4, Z is 3. Part 2 matching gives X plus Y equals 6, XY equals 8, and 5 plus Z equals 5, so Z is 0. 2 numbers with sum 6 and product 8 are 2 and 4. Either assignment works. Part 3, the total is 9, and y plus z is 7, so x is 2. From x plus z equals 5, z is 3, and then y is 4. Question 7. 4 unknowns hidden in one matrix equation. Matching the 4 entries gives 4 equations that solve in a neat chain. Write out the 4 equations from the 4 positions. Subtract the first from the third. A equals 1, and then b equals 2. With a known, c is 5 minus 2, which is 3, and d is 13 minus 9, which is 4. Question 8, a definition check. When is an m by n matrix square? Square means as many rows as columns, m equals n. Nothing more, nothing less. Question 9, and ir is a trap. two matrices that look matchable. Which values of x and y make them equal? Let's try to match the entries and see. The top right entries force y. 5 equals y minus 2, so y is 7, and the bottom left agrees, since y plus 1 is 8. But x is demanded twice with different answers. 3x plus 7 equals 0 gives x minus 7/3, while 2 minus 3x equals 4 gives minus 2/3. One symbol cannot take two values, so no choice of x and y makes these matrices equal. The final question, a counting one. Every cell of a 3 by 3 grid independently holds a 0 or a 1. There are 9 cells, each with 2 independent choices. 2 to the 9 is 512. That completes exercise 3.1. That completes all 10 questions of exercise 3.1. In the next video, we will take up exercise 3.2 on operations with matrices. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.